Hey guys, so this morning we're going to be going over some of the practice problems we've done, and if we get stuck on anything or there's just any more clarification, maybe we'll pick up on any of the other practice problems that we've shifted into trying here. So this is one of the websites that has coding practice. Now there are solutions for these as well, so you can check yourself, or if you get super stuck, you can peek. Although, of course, then you don't learn as much if you do that. But before then, we're going to go back and go through all of the exercises that I'd come up with myself for my friend, and then make sure that we're solid on all of this before we go ahead and move on. So I set breakpoints on all the ones I don't think we talked about. So this first one is talking about a function that takes in integers and returns the list that has the element passed in an earlier index in the list. And I say you can assume that the number exists in both lists, don't use loops. I'm just gonna go ahead and talk through these. And then if you have any questions, Audie, you can stop me and we can talk more about it. But this one was supposed to be easy. And as you see, it really is. You just check the index that the number is in both lists. And then, if it's less in the first list, then you return the first list, and otherwise you return the second list. Really is that easy. So I mean, this is good. The intent with some of these earlier ones was just to show you the power of using function calls, calling other functions to do the things you want rather than having to do it yourself with a loop or conditionals or whatever. If you can call a function, import a library, call someone else's code to do what you want, usually you can save a lot of time, right? And so you could also do this one by going through each list in a loop, setting a counter variable, incrementing the count variable until you find the number, and then comparing them. But that's a lot more work than just calling the index function, right? We have another one where we wanted to check if string 2 and string 3 were in string 1, and then return true if so, false if otherwise. Again, this is another thing just showing the power of using this time, it's not so much a function as a language feature, right? We have, how do you check if one string is in another string in Python? Well, you use the in keyword here. And so if this string is in this string, that will return Boolean value of true. And then same thing for this one. And then we AND them together. And there you go. So not going to talk more about that unless you have questions. But both of these were trying to show that, hey, doing some of these things isn't always going to be so bad if you use the built-in functionality or you use keywords. Some of these from the first set of warm-up problems here are pretty similar. I haven't looked at all of them since I first skimmed them, but a lot of them are like these problems that don't use loops are going to be only 3 or 4 lines long, like some of these. Okay, so that was the first two here. We'll go ahead and take the breakpoints off. We'll keep going through our list. Okay, so this was one that I think I actually did want to talk about because I had intended for this to be done, I think, without loops. And then I hadn't actually typed that so much. Let's actually go through this one here for just a second. So let's uncomment what we have here. So this function at a high level was going to be about, okay, so a worker has a dictionary, it has a map of the workers that they have, and then the number of projects they worked on and how much income they brought in from the projects, right? So the company wants to award their highest performers by giving everyone who brought in more than $100,000 a bonus. So given the dictionary as an input and also a specific employee name, return a Boolean value representing whether or not the given employee should receive a bonus. And here I just said without loops. So, and I hadn't put the without loops initially, but I want to show along the same lines that we were just talking about, how this is actually easier if you lean on some of the functionality of Python than if you do it yourself. Because you can do it yourself, and we'll go through what you did first, but then we'll show how this actually becomes a lot simpler if you just use indexing into the dictionary to do this. Okay, So do you want to try to explain to me what your code is doing here?
Yeah. So what I did was try to find a way to go through the dictionary one entry at a time.
Mm-hmm.
So that for each key and value, the dictionary could check whether the key corresponded to the company employee. Then if it did, it would check to see whether the thing that the key corresponds to is a list. If it's a list, then it checks to see whether multiplying the values of the list, since we're looking for the total dollar amount that the employee brought in through the projects they did, is greater than 100,000.
Mm-hmm.
Then it returns true. If it is not greater than 100,000, it returns false. So it just checks to see which employees actually brought in more than 100,000 and tells us, yes, this one did, and no, this one didn't.
Right. Okay. So only thing that I have questions on is what exactly is the purpose of checking if something's a list? Is that something that we need to check here?
I thought it was because I didn't see any other way to check the total value. I had to multiply the two entries, and I couldn't do it without establishing for Python that thing is a list. At least I didn't know any other way to do it. I had to tell Python, if it is a list, then you can do the multiplication.
So you're saying that if we don't do this, it's not going to work?
I haven't tried. So
let's try it. So we'll shift that over one level, so not nested as much. So here's the tricky thing. In languages that are strongly typed, you always know the data types of things. You don't have to guess by looking at your code. So in things like C# or Java or C or C++, all of those languages make you declare a data type for every single variable you use. Now, sometimes you can get lazy and use a keyword called var, V-A-R, which will like infer the data type for you so that you don't always have to sit there and look at it and try to figure out what it should be. It's called type inference, but in those languages, every variable has a data type. You're never unsure as to what data type something is. And so I kind of see why you would say, you know what, we want to be doing this operation on a list. What the intent is that we want to be multiplying these things, and these things are in a list. So your code is not going to not work here. In general, though, if we ever do something in our code that's not strictly necessary, it will just end up confusing people who come and read it later. So the question here will be, get rid of the breakpoint here. So the question here will be, will our code work if we don't check the value? Actually, let's first run it just to show that it does work if we do what you did here. So if we check the value, we make sure that it's a list first. Oops, you know what? Running is not what we want. We want to debug. All right, so we're going to stop. Why did we not stop there? Huh, that's interesting. Let me try refreshing the project. Breakpoint's supposed to stop on line 723. Very strange. Wonder if there's something I'm missing with the debugger here. Well, at any rate. All right, so step.
I have problems with it sometimes. That's why I was actually wondering.
Oh, I see. I see.
How to figure it out.
This is indented. It was actually inside the function.
Okay, okay.
So I wonder if I messed that up just now or if that was messed up. Huh.
Then
Well, now we should hit the breakpoint. Okay. So let's go ahead and let's get into this. So now we're inside the function. Okay, so we're going to go through, and when we go through, we're going to find the one who's the right employee. Okay, now we found the right employee. So when we do this, if the type of value is list, we're going to go in. And so the type of value is list, but the key point that I'm trying to make here is the type of value will always be list, right? In this particular set of circumstances. And so then we return true. Okay, so prints true. Now, if we go back and we do this again, and we get rid of this, and then we shift that out in indentation level, and we run through this again. Okay, so we still go through the employees until we find that one, but you see how we just immediately jump down and we end up getting the same result, right?
okay. Okay.
Now, so that was just something I wanted to point out. What you have isn't wrong per se. It's just, it's not actually necessary to give it that data type because you are allowed to index into something, you know, without formally giving it a type in Python.
Okay. Okay.
Okay. Now, something else for us to look at is, let me do this how I had intended for us to do this. If you look here, I had said, hint, look up methods on dictionaries on W3 schools, especially accessing elements by key. And so what I had meant by this wasn't necessarily that you go and you iterate through. See, I didn't actually say no loops when I had originally wrote this, although that's what I meant here. So the simplest way to do this, rather than going through the things and getting a key. So in your head, what exactly does COY stand for? Do you remember anymore?
Yeah, it means company, company employee.
Oh, company. Okay, gotcha.
Yeah, that's when we write it here.
Interesting. Never heard that abbreviation before. So let's go on W3 schools. Look up the dictionary methods like I'd mentioned. And my hint here on this one had been to look, especially accessing elements by key. So we're looking for a dictionary method that lets us access elements by key. So we go to methods. And how about this one? Returns the value of the specified key. Right? Okay, so if we have a dictionary called car, we want to get the one that has a key called model. Right?
Yes.
And so here, if we want to get the price of a car, you know, seems simple enough, right? So if we go here, what we'll do is we'll have worker dictionary, and then we want to get the value of this key, right? So we'll get on this, and then at what point in your code, like let's assume this works. At what point in your code does this get us? Like line 714, 715, 717. You see what I'm saying? Like which line up here, if this line returns successfully?
I would say 715. But that's checking to see if the key. Yeah, I think so.
After 715, after we step over 715, and after we step over this line, you were correct. We will be at the same place. We will have gotten, we will be at a place where we have the value of that particular key in the dictionary. But in this way, we don't have to write any loop or think about going through it. We just say, hey, dictionary, I want this value, right? And we're actually kind of assuming here that this value exists in the dictionary. If we didn't assume that, we might have to wrap this in a try except block. But the rest of this function for us is easy because we just do the same thing we did before, right?
Yeah.
And you should not be so indented, right?
Yeah.
Except we actually need to okay. So let's do this function now, and we expect this. We expect this to return true, right? Because that's what the other one was returning for Ashley Carter, at least, right?
Yes.
So we return this, or rather we debug, and we step over it. Return true, right? Okay.
Yeah.
And then just to double check ourselves, let's go find someone who shouldn't receive a bonus. Stuart here, not going to quite make the cut there, just a little under 100,000. So if we, in our call here, replace that with Stuart Duncan, then we run our debugger. All right, well, once we step inside here, we'll see that when we get the value here, Stuart's number of projects and things, he should end up at like 90,800 will be his total. But his salary, okay, let's step. And now we should have a variable for value. Okay, now we have Stuart's list, right? And this will come back and we will jump to the else case here, because this will return, like I said, 90,800, which is not greater than 100,000. And it returns false. Okay, so I know that was maybe a lot of talking for me to just say, hey, there's a function that does this thing where you get the key of a dictionary, but it's very valuable because suddenly you don't have to write the loop to go find something. And in fact, let me show you that there's a parallel thing in lists. So there's a function for a dictionary that gets the key in the dictionary. Well, if you want to find a specific item in a list, you can do that with a loop, but there's also Python lists. There's also a method for lists here that where you can find an element in the list. Might not actually know it off the top of my head. Count, reverse sort, remove, pop, insert, index. Yeah, it'd be this one. So you can give, you want to find the index in the list where the fruit is cherry. So if you call this code right here, this should return 0, 1, 2, and then you can use that index to access that element in the list. That's a lot easier than looping through the whole list yourself, right?
Yeah.
Okay, so you can do the same thing for lists. That's what I'm saying. And if you wanted to be kind of sneaky about it, if you want to, like, I guess this isn't so useful because if you know the thing, then why are you getting the index of it? But I mean, the point is that like you can use functions to do things that you might otherwise use simple for loops for, and it makes your code more readable. So, all right, I'm going to stop yammering there. That was this one. All right, so take that breakpoint. Go to the next one. Okay, now we're on the palindrome problem. So these were after we'd done loops, and now we're going to be checking palindromes. So this first time, I said that we were supposed to write a function that checks if a given string's a palindrome. It's the same frontwards and backwards, returning true and is and false otherwise. So example is race car. In this implementation, you may not use a second string variable to reverse the string. So there's obviously, like most programming problems, several different ways to do things here. But let's go ahead and step through this one here. So we have a longer string here. You know, for the purposes of debugging, I might make it a little bit shorter here. Let's make our string here. Let's Let's make it race car because that's not so long. Okay, so we run, and then before we look at the code, we're going to start with index 0, and while index is less than the length, we're going to check if the input string that we have, if the input is the same as its input backwards. And then we're going to keep going. So I have a question here. How many times is this loop gonna go? Like, how many iteration cycles will it make relative to this variable?
It should just make it for the length of the string. Just
Now, let me ask you, once you've gotten halfway, have you compared all of the first indexes and the last indexes?
Yeah, it doesn't need to actually do the whole length. Yeah, because
now,
halfway.
What happens if you have an even length string and an odd length string? So
I thought about that, and I wasn't sure what to think. But if it has an even length string, then it will have a mirror image with no both sides will actually be exactly the same. If it's an odd length string, then there will be one character that stands right in the middle. It's not reflected. Yeah.
Now, does that bother us? If there's a character in the middle, does it matter what that character is for it to be a palindrome?
I don't think it does.
Now,
I don't think it does.
Before we get here, let me say x equals, let's use an example. Let's use a simple case. Let's use 5. Okay. And then we're going to say y. And then what we want to do is we want to print the value when we do x divided by 2, right? You'll see that Python will actually return something that's not an integer here. So what we want to do is get how many times this goes into that without a remainder, right? So 2 goes into 5, 2 times remainder 1, right? So let's see what happens when we print this here. It should happen is we get 2.5. So Python assumes, okay, we're doing x divided by 2. That means we want to actually get what it is, and that returns actually a different data type. In most programming languages, x here would be an integer, and this is a floating point value or a double, right? So here, let's say Python int division. I actually don't. I know you can do this. I don't remember how. So it says
it's backslash or something. Okay, no, that's for the modulus.
All right, so floor, that's easy. That's what we want, right?
Yeah.
So I mean, there's probably multiple ways to do it syntax-wise, but let's try using floor. Oops, so if we can't. And then we do that. Oh, okay, doesn't like. I wonder if I have to import something. Okay, let's try the thing that looks like built-in syntax here. So it said if we do //, it'll do integer division. I bet it's just like I have to like import math or something there.
Yeah, it appears to run it.
Yeah. Just clear out the console there. Okay, so this one is doing what we want. It returns 2, the part without the remainder. Okay, so where I was going with this was that if we have the string here, Actually, let's test it. So my whole point was that your loop here is fine, but you end up double checking some stuff, which isn't so great from an efficiency point of view. So if we do integer division right here, so that we get the integer value of this, I want to convince you that it doesn't matter if we have an even number of inputs or an odd number of inputs. So let's start with the even case. Create that a string of all e's. This is a palindrome. It's the same frontwards and backwards, right? And so when we get here and we step over this print statement, we should get true. So we step over this. This should be true. Well, okay, you know what? And continue to the next breakpoint here. We get true, right? Just set something random there so that I can set a breakpoint on it and it's easy. Okay, so now if I remove one, now how many times will this loop go?
Go through the EEE.
Through this input.
Yeah, it should go through it twice or once.
So while index is less than the length, so less than the length divided by 2. The length divided by 2 is what here?
1.
1. Okay, so index starts at 0. We do the check, and then we increment by 1. Is 1 less than or equal to 1? So actually, this one will go twice. And that's sufficient because you are actually handling the middle case. I think it would actually work if you did strictly less than as well. Do we expect this to be true? I think you can actually take this, you can actually take the less than away as well, and then it'll only go once. And I think this will actually also be true. And does it make sense to you why if we remove the equal to, it works as well?
Yeah.
And so removing the equal to means we save an iteration cycle most of the time. Because we only check, so in this case, we only go twice. And then in the case of 3, we only go once. But we don't have to check the middle thing because the middle thing will also be equal to the middle thing going the other way.
Yeah.
Okay, so what you had was basically the right way. We can just make it a little bit more efficient by not double counting stuff.
Okay.
Does that all make sense?
Yes, it does.
Okay. Moving on to the next bit then. Let's stop in the debugger. So now we had doing this same thing, but reversing the string. Reversing the string is kind of conceptually the easiest way. This is pretty efficient. This is smart. But if I especially take someone who's not a programmer and try to explain to them what I'm doing, you go through half the length of the indices and you compare that index going forward in the string to the index indexing backwards in the string, they're just going to look at you weird. Well, conceptually, how do you check if something's a palindrome? Is you check if the string's the same forwards and backwards. So you get the string forwards, you get the string backwards, and then you see if they're equal to each other, right? Very intuitive way to do it. Now, the problem with this one initially, and this was one that you had messaged me about, was you had actually started this one out iterating with the length of palindrome 2 in the while check. And this is very similar to that case that I had mentioned to you about when I was in college, where I was like iterating over the length of a list, and then I was changing the list as I was iterating over it. And this leads to really, really hard to track down bugs because it's not like syntactically invalid. It's a logic error. It doesn't do what you want it to do. And so you were having a problem that it was just stopping iteration too soon. You were going through it and then it would stop and you would be like, well, why is it stopping? I don't understand. And so you did the easy way here is you make a copy of, or not a copy, you get the value of the integer, but then you don't check the length every time. You just check the length of what it was from the beginning, right?
Yes.
Yeah, and that is the solution to the problem that you had here. And other than that, what you had was fine. Okay, so we start out with the count variable in the new string. While count is less than the length here. So we're going to go over every single index in the input string here. We are going to make sure that the string is not empty. That's what this is supposed to do, right?
Yeah, it does that. I was actually saying what I had in mind more was you're going through the string. If this is the last character on the string, then do something. That's what I was actually saying. So, but I guess it also does the whole checking to make sure
So
the string.
This is another thing here of, do we need this check? If we are accessing the last character of the string, do we care? Iteration wise?
That's true. We probably don't.
So I think we can actually, I think we don't actually need this check because I don't think it's giving us any, oops, using the wrong short key, the wrong, I don't think it gives us any information there because you see how we're accessing this anyway, right?
Yeah.
It's because we're indexing. We're not going through the loop and then stopping once we find the last index. We're actually directly accessing the last index. Okay, so that makes more sense. Now I see what you were trying to do with it, but I don't think we actually need that. And so then we build the new string, which we have the variable up here, and we concatenate to the new string the last character that we're doing here, which means we'll build the string backward, and then we increment the count, and we can then check it and then we get rid of one index from this string, right?
Yeah, we drop off the last character, yes.
Okay, so this will work. Do we have something that calls this? Doesn't look like it. So if we do that should be what do we call this variable? Palindrome 2. Live on time equals admit no evil. So you better be on time. Something else to give my breakpoint to. And so we expect this here to return true, right?
Yes.
Or actually, right now we're having it print. What was this? Same function, but yeah. So this actually shouldn't print the string, it should print true, right?
No, it should print the string. It doesn't check whether it's true or false. It just returns the new string after reversing it.
But wasn't the function here was supposed, it says write the same function, but this time you must use a second variable to reverse the string. Okay, I guess I didn't. But when I said write the same function, here, let me show you. It's really easy. What I was intending you have happen was this. That you check if the new string that's been reversed is the same as the old string. Yeah. We want to check to see if the string's a palindrome. It doesn't think so. So let's set a breakpoint and see why it doesn't think so.
I think you changed it to race car. Right?
No, it's because what have we done to the initial string here?
Not sure.
You see the value of palindrome 2?
Oh yeah.
We're trying to compare it. This is, I just made the same mistake that we had initially, right? Is that we changed the value of palindrome 2. So what we could do, just how you made something so that we weren't, you weren't doing it, we could do copy input. one way to do it, I think. Although
Okay.
to be sure, I'll have to find out here in a second, but oops. I think this should actually have both of them copy of input. Those look the same to me. So when we step here, this should print true. Yep. Okay, so just like before, I'm going to try to have us do this a way that perhaps is a little bit cleaner. The way that you have it working right now is fine, but you see how we have some challenges a little bit going through, and because we're like changing this thing that we're iterating over, it's just kind of hard to think about for one. So what happens if we don't modify the string at all? We just go through the indices backwards. So when we reverse the string, let's do, and I'm going to have to go pretty soon, by the way. But I do want to get us through this. So you can actually iterate over the range of indices for something backwards. So we can do a for loop here, except for y in, and then we are going to give the range function an interesting set of arguments here. We're going to start with the last index, right? So the length of our palindrome 3 input here. Okay, so that's the first one. And then we're going to go through -1, and our step is going to be -1. So we have start, stop, step, right? Those are the inputs to range. And it doesn't like. There we go. Do you know what this function is going to return here?
Yes. Okay, hang on, let me see if I can get it. It starts from the end of the string. You have a capital S instead of a small s.
Yes, I do. This is going to get the indices from the end to the beginning first, and it will be stop at 0 because our stop is -1 and our step is 1. So once we get to something that would be -1, then we stop. And so
I thought -1 is supposed to be like the last character on the string.
The inputs to this function here, range, stop, right? Start, stop, step. Return an object that produces a sequence of integers from start inclusive to stop exclusive. Remember that stop, we don't include the last index for stop.
Oh yeah, okay, I get it now. I get it. So when it iterates from right to the end, it has to be -1 since
just how normally when we iterate over indices, we give the stop parameter to be the length. We start at 0, we stop at the length, but the length is actually 1 more than the last index, right?
Yeah,
so this is 1 more than the last index for us, because the last index when we go backwards should be 0. Okay, so if we give this one, we'll pass it palindrome to whatever. You know. But you don't need to name the thing that you pass it. You don't need to name the thing that you pass it the same as the variable inside the function. It's an important concept here. So in fact, let's get rid of this naming business here. And let's just show you that we can name this string up here palindrome, and then we can pass it to the functions, both of them, even though the names are different. So print a separator just so that we see that we have these variables here. Okay, so we expect both of these things here to return true. I must have still had a breakpoint set. String index out of range. Huh, maybe my code doesn't do what I think it does. Oh, whoops. I need it to be one less than the length rather than the actual length, because the length is one index greater than, silly me. You see what I just did? I added a length minus one, because that gets the highest index. The length is one greater than the highest index.
Okay.
All right, well, it doesn't think that maybe I have something that's not quite right in my function. Set a breakpoint and let's try running it again. My point was that you should be able to iterate over without actually changing. Oh,
Okay.
Well, okay. Do you see my problem? I see my problem.
What was it?
I'm checking if it's equal here. That's what I want to do at the end. So my brain is being derpy this morning. This needs to be that. Previously, I was just checking equality. Now this should actually work. I don't know why I was doing that. It's just being silly. And then continue. There we go. Does how I did this make sense here? And you see, this I think is a little bit easier to understand than actually changing the other string, right? So we're going through the indices backwards, and then we're building the new string, and then we're returning if the new string equals the old string. This is how I had, quote unquote, intended for this problem to be done, because it has you go backwards over the length. This is just showing you that you don't have to iterate in the forward direction. You can go backwards over a collection as well. So we're out of time here. We can go over this one the next time we meet formally, if you think you need it. Actually, hold on. Let me look real quick. If you got it, then I may not talk about it that much. So return if that is greater and return. Yeah, this is exactly how it intended for this one to be solved. So if you don't have any questions on it, we can conclude our discussion of the exercises that I came up with. We can conclude it here. Because this one is, like I said, although actually, you don't need that again. That's not necessary for the same reasons that we talked about just before. All right, well, I really have to go to my meeting, so I will talk to you next time we meet then.